So we stopped at question 7 and we're now just about to begin question number 8. Okay, and I just mentioned that to solve this set of simultaneous equations we can follow 2 different methods, and I will show you both methods to solve this question. Okay, and we're solving to find out what x is as well as what y will be. And to all the people that are joining, this is a foundation grade 5 mini test, okay, that you can easily get from Maths Genie. It's just a collection of different grade 5 topics. Okay, Saria, how have you seen the EdQuest? You mean the GCSE Maths paper? I haven't seen the GCSE Maths paper one yet. No, I'm probably gonna see it next week. Okay, but I did hear that it was easy, so I'm hoping that's good news for the higher lot. But in terms of grade boundaries, I'm not quite sure how that's going to play out. But at least during the test, it wasn't too hard for most people. How did you find it? And whilst you're commenting, I'm just going to start with this question, okay, on simultaneous equations. So I've got my set of equations, and the way I'm going to go about it is, can you see that clearly? Zoom in a little bit. Okay, so the way we're going to go about it is okay, Saria, so you wanted to know what will come. Okay, I'll need to look at the paper because I can't really tell. I haven't seen the paper yet. I heard it was easy from the higher people. I'm not sure about the foundation paper as such. But I'm going to begin with this topic. Okay, welcome to all the new people that are joining. Alright, so the method I'm going to start off with first is called the elimination method, okay? So for question number 8, if we eliminate one variable, elimination actually, then we can sort of work out. Thank you for all the gifts people are sending and the shares. Please share it with lots of people that might need it. We have got 2 more papers for maths, so I'm hoping that this can really help people out. Thank you for the shares as well. Okay, so the elimination method is as follows. We take one variable and we try and eliminate it, okay? So in this case, I'm going to pick the y because it's going to be easy for us to eliminate because we've just got one y here. And if I change that one y, so I'm talking about this one, into a 4, okay, by multiplying it by something, then I can easily eliminate this variable, okay, which you'll just see. Yes, so sorry, you've got it. Multiply the top by 4, okay, and I'm going to keep it positive 4 because that's when they can both cancel out, okay. So I'm going to times the first equation by 4. We'll also be labeling these as 1 and 2. So if I multiply the whole of the first equation by 4, that means every single term. So I'm going to write down here 1 times by 4. That means 3x becomes 12x. 1y becomes plus 4y, and 11 becomes 44. Okay, and the second equation stays the same, and that's where you'll see the magic happening, hopefully. So 2x minus 4y equals negative 9. It's going to stay as it is, and then I am going to now perform a calculation in order to eliminate this. Can someone tell me in the comments whether I'm going to add these 2 equations or subtract them? And I'm bearing in mind I'm trying to eliminate the middle bit over here, these 2 terms. Subtract. Okay, Saria said to subtract. Does anyone have anything else to add to that? Who is that saying I'm confused? Enit. Erita, sorry, I can't say the whole name. Erita, you probably are confused because you've just joined. We are solving simultaneous equations by the elimination method. Okay, so it won't be, no, Erita, it won't be subtract, because if we subtract these two variables, if we subtract these two equations, I'll show you what happens. So we've got plus 4y. If I take away a negative 4y, if I do that here, then what's going to happen with these two in the middle? Okay, you're just copying, sorry. That's fine, but okay, so that means you're not a student, I believe. So what do you think is going to happen when we've got two negatives next to each other? Plus, exactly, Saria. So if they change to plus, it becomes 4y plus 4y, which is going to become 8y, okay? And that is not what we sort of want. We don't want to add, we want to eliminate them. So the answer should be coming to 0, okay? Yes, two negatives make a plus. So we don't want to make it into an addition calculation. We want to subtract so that we are left with 0y. The way to do that is to make this an addition calculation, okay? That's when the negatives, that's when it will cancel out. So 12x plus 2x, we get 14x. 4y plus minus 4y, well, that's just going to be 4y take away 4y. That's gone. That becomes 0. So I'm not going to write anything here. Equals 4y minus 9. 4y plus minus 9 is just taking away 9, which means we are left with 44 minus 4 is 40, minus another 5 is 35. Okay, that means I've got 14x on this side equals 35. And if I solve this equation, I would get a value for x. Any ideas what x might be? Brilliant, sorry, that's it. 35 divided by 14. Okay, we can leave it as a fraction as well. Okay, and simplify it. If it doesn't go into it fully, but what was I going to say? Yeah, so I'm going to divide both sides by 14, here and here, and then what do we think we are left with if we simplify this? That's it, Sari. So yeah, we do substitute it back into one of the original equations, but before we do that, we're going to sort of simplify our answer, okay? So try and cancel down and look for the highest common factor, basically. So 35 and 14 both go into the 7 times table. So if I divide the top and bottom by 7, I should be left with, at the top is going to be a 5. And at the bottom, 40 divided by 7, I should get 2. So it's just 5 over 2, okay, for x. So we've got our x variable. Okay. And now to work out y, we're going to substitute the x variable in one of the equations at the top. And I think the simpler one is just the first equation. Okay, so I'm going to substitute x into the first equation. So x, substitute 1 into, substitute x into equation 1. I'm just going to write EQ for 1, okay? And when we actually do that, we are left with 3 times by, 3 times by x, which is 5 over 2. Plus y equals 11. Okay, so then once we actually do that, 3 times by 5 over 2, I am left with 15 over 2 plus y. Just checking I'm doing that correctly. Yeah, plus y equals 11. Okay, have we got any other comments? Okay, and then it's just a case of us rearranging this. Okay. Yep. So that means we've got y is equal to 11. We're going to subtract 15 over 2 from both sides so that we can take it to the other side. Okay, so if I minus 5 over 2, sorry, 15 over 2 from both sides, it gets cancelled out from my left side, and on the right side it's just going to be y equals 11 minus 15 over 2. Okay, so now it's a case of doing your subtraction with fractions. Okay, so the way we can do that is, any ideas from anyone? So the way which we can do that is, if we take the 11 and change it into a fraction, so we want it to be, so 11 as a fraction normally is just 11 out of 1, but we want the common denominator so that we can subtract our fractions. In order to do that, let me just show you on the side. I'm going to times the top and bottom by 2. So I've got 2 as my denominator, and 11 times by 2 gets me 22. So I'm going to rewrite this as 22 out of 2 minus 15 out of 2. So therefore y is just going to be 22 minus 15, okay, which is just 7 out of 2. Okay, let's move it up. So that is your y. So that is the elimination method, okay, in which you can work out x and y. There is also something called the substitution method that we could also use to calculate the values. Does anyone want me to go through the substitution method, or are we good? Well, so far I think it's just Saria. Where's everyone else gone? Good, thank you. Okay, right, so I'll move on to the next question, which is question number 9, about a right angle triangle. And whenever we see that, we should straight away think that it's either going to be trigonometry or Pythagoras. Okay, in this case it's telling us to calculate the missing length AC, and we've been given 2 lengths already. So straight away we should be thinking in our minds that this is a Pythagoras question. Yeah, that's it. Okay, so it's going to be Pythagoras 1, which means that we need to write the formula straight away. And do we remember the formula? Comments? It's so hard to read the comments on this. A squared plus b squared equals c squared. So yeah, that's it. Okay, that is correct. So we're writing that down. Equals c squared. And also need to label my side so I know what to substitute where. Now side C is always the longest side. Okay, it's the hypotenuse, which is my AC, this long side. Okay, so that is my C, and A and B you can label in any order. It doesn't really matter because we are just going to be adding them both anyway. Okay, but C matters, so we need to know where C is. So if I put in 7.6 squared plus 5.7 squared equals C squared. Okay, and an easy way to do it is just straight away in your calculator. This will hopefully be in your calculator paper. Just do C equals square root of 7.6 squared plus 5.7 squared. Okay, and that is going to be equal to, welcome everyone, thank you for the shares, welcome Ariba. And oops, let's go back. No, I don't want any of this. Oh goodness, who has done something with my calculator? Calculate. Okay, so who's that saying hi? Oh, that's Ariba. Okay, welcome Ariba. So we are just calculating this. That is the square root of 7.6 squared plus 5.7 squared. Oops. So it is equal to 19 over 2, and we want it as a decimal. So let's change the settings. 9.5. Okay, and that's all. 9.5 centimeters. Okay. A squared plus b squared equals c squared. Yes, Ariba, that is correct. So this is a Python question. Okay, moving over to question 10. It's a sort of a different one about percentages. Lottie bought a house for £350,000. In the first year, the house increased by 2%. In the second year, the house price depreciated by 5%. Okay, so I'm just underlining the key information that we probably might need for answering this question. Work out the value of the house at the end of 2 years. Okay, so step by step we need to do it. This looks like a percentage increase and a percentage decrease question. Okay, so if we think about first year, what happens, and then we can think about the second year after that. So first year our value was always 350,000, but the house price increased by 2%. Do we know how to show a percentage increase of 2%? Now there are many methods which we can do it. There's a multiply method, and then decimal multiply method, and then there's also just a normal method which we use without a calculator. Anyone know what it might be? $1.02. Brilliant, Saria. Okay, where is everyone else? I feel like today people are not as worried about revision as they were last week. But that's correct, Saria. So you've done it using the multiply method, okay? Which is where we say, because all percentages are out of 100%, and 100% is our original value of £350,000. So we want to increase by 2%. So my multiplier would look like this: 100% plus 2%. Well, that equals 102%. And if I divide this by 100, I would be getting 1.02, okay, which is my multiplier. So for the end of the first year, it would be 350,000. If I put this in my calculator, times by 1.02. This will then give me the increase question. Oh, no, I'm sure it'll be fine. Yeah, I heard mixed comments. So on TikTok, everyone's saying it was difficult, but in my school, the girls were saying that it wasn't, so I have to see the paper myself before I can decide. But you know, definitely I'm sure that they will even it out. So if paper 1 was hard, paper 2 and 3 should not be too hard. So if we pop this in our calculator, 350,000 times by 1.02, then we get 357,000, which seems reasonable. Always check that your answer seems reasonable. If it's only increased by 2%, the value should not be something dramatic like £400,000. Okay, so you'll know that you've done the calculation correct if the answer is reflecting the question. Okay, that's just an important way to check. And then the second year, we are going to take this value of 357,000 and we're going to depreciate this by 5%. Now again, we need to work out the decimal multiplier. So let me know in the comments if you know what the decimal multiplier will be for this depreciation bit. Sure, Saria, but Edcast, where are you from? So I've never heard of this. I mean, I've heard of GCSE, you know, there's Edexcel, there's AQA, there is OCR. These are all the exams, you know, companies, but I've not heard of that one. 1.95. Oh, not quite. Okay. So as we know, all percentages are of 100%. That's my original value, 100%. If it's depreciated by 5%, I'm going to do 100% minus 5%. Okay. And therefore, I will be left with, if I do it here, 95%. Okay. And if I divide this by 100, what do I get? That will be my decimal multiplier. Any ideas? You're back. Okay, great. Any ideas what that would be? 95% divided by 100. Zero 0.95. Yeah, that's right. Ariba, well done. 0.95 it is. So I'm going to now multiply this by my original value, okay? Times by 0.95. And let's see what the answer is. 1000 times by 0.95. Okay, so as we can see, it's a lower value, which makes sense because we are meant to be depreciating the price, so it should be getting lower. So it's £339,150, and I will write that at the top here. £339 and 150. £339,150. So girls, can you let me know where you're from? Because I don't think here in the UK they do Educast. The exam board that you're talking about. You're from UK, okay, but I've never heard about Educast. Okay, probably it's a new one because it's usually OCR, Edexcel, or AQA. Okay. Yes, that's probably why. But where are you from? Oh, it's only 2 papers. Okay. First I've heard of that paper. Devon, okay. All right, okay, and you both are doing it. Yeah, I've heard about Devon. No, I don't think I've heard it. You're from Bradford, okay. Nice. Well, Cornwall. Oh, that's near. Is that near Birmingham? I believe. Okay, so moving on to the next question. I've only got 10 more minutes, okay, girls, before I have to go. So I'm going to try and do as much as I can. So we've got write down as a column vector 3a minus 2b. So we've been given a, we've been given b vectors as well, column vectors. What we need to do to work out 3a is just to multiply the whole vector by 3. So 3 times by negative 3 and 5, what we should be getting is negative 9 and then 15 at the bottom, okay, for my vector, and then minus 2b or let's just do 2b and then we're going to take away afterwards. It's going to be 2 times by b, which is 4 and 2. And if I actually multiply this, I get 2 times 4 is 8, 2 times by 2 is 4. Okay, and at the top, I'm going to show you how to subtract them. So 3a first, minus 9, 15 at the bottom, minus my second vector of 8 and 4. Okay, yeah, but just don't use, so you do it without the a and just times it. Yeah, so 3a here, girls, just means that the vector a, okay, which is this whole vector here. It's a column vector. This is the x direction, this is the y direction, okay, that they're sort of telling us about the horizontal and the vertical directions. And 3a just means you're multiplying the whole vector by 3, okay. Exactly, and 2b just means multiplying the whole vector b by 2. So if I actually subtract these two now, I get minus 9 minus 8, which is going to be negative 17, and 15 minus 4 is going to be 11, okay, and that's my answer. No problem, I hope that made sense for you. So that's all for that question, and then question 12 is a sketching sort of one with probability. Okay, so for question 12 what we've got is Tina has 2 bags of counters, bag A and bag B. There are 3 counters, 3 red counters, so if I underline the key bits, and 4 blue counters in bag A. There are 5 red counters and 3 blue counters in bag B. Tina takes at random a counter from each bag, okay, and then you are meant to draw a probability tree diagram to represent this. So no calculation, just that probability tree diagram, okay. So let's go ahead and sketch this out. So the way we're going to do this is question 12, grab my pencil. I could be doing it with the ruler, but I feel like I'll be fine without one for now. But ideally, girls, I'd say use a ruler for this. So my first tree that I've sort of drawn, the branches, is going to represent bag A. Okay, the choices that we have from bag A. So if we go back to the question, it says 3 red counters and 4 blue counters, okay. So if I write down R for the first branch, which is for red counters, and B for the blue counters. So for the red counters I've got 3, and it is out of in total, how many counters are there, girls, in bag A? 3 out of 4. Oh, so not 3 out of 4, girls. That's where often everyone makes a mistake. It should be 7. Yes, Ariba, that's correct. And sorry, you corrected yourself. 3 out of 7, okay, because in total in bag A, if you think about it, you do 3 plus 4, you'll get 7. So only 3 out of the 7 are red, which leaves us with 4 out of the 7 that are not red, okay, that are blue. And now I'm going to draw another branch coming from the red, which will be my bag B, okay. So this is all for bag B, the second column that you can sort of see me drawing of branches. So that means what it's trying to show is that from bag A, for example, if I choose bag A first and I've picked red, then next I could have picked from bag B red again, or I could have picked blue, okay. But alternatively, if I went ahead to bag A and I got a blue one instead, then I might pick a red from the bag B, or I might pick a blue one first and then a blue one again from bag B, okay. So it's showing you the different combinations that one could have if we had if we were picking those counters, okay. So let's go ahead and finish the actual tree diagram. So for my red branch for bag B, it says 5 red counters. Okay, so I'm going to write down 5 out of, so it's 5 plus 3, which is 8. 8 in total. And then for blue, there are 3 blue counters out of 8. And I'm just going to repeat these values again for the second branch. And that's it. Okay, so for this, girls, we are just doing the sketch of the tree diagram. There's no calculations involved, no probability that we need to actually calculate. So that's all for this question. And I think I'll do one last one before I get going. So question 13 is saying make A the subject of V equals U plus AT. So A is making it the subject. So let me rewrite the equation. So the word subject, oh, I'm glad you found it easier, but yeah, so that's the easiest bit, but that could be probably like your part A of the question in the paper, GCSE paper, and part B might just be to calculate a probability. Let's say if you picked a red counter first from bag A and then from bag B picked blue counter, what's the probability that will happen? Okay. But question 13 is asking us to make A the subject. Okay, and to make A the subject, it means we just want A on its own and everything else on the other side. Okay, so the way which we can do this is, let me just zoom in a little bit. Any ideas, girls, how we might do this? Okay, I think I'll go through it. So to make A the subject, we want to eliminate and get everything on the other side. Okay, so I'm going to start off with the U. Okay, because there's nothing attached to the U. It's just sort of sitting there by itself. So I'm going to take the U onto the other side. And to do that is I'm going to do the inverse. So currently U is being added okay, to 80. So I'm going to subtract U from both sides. Okay, and when I do that, these two U's cancel out, and on the left side I'll be left with V minus U equals AT. Okay, now I can slowly see that I've got a still left okay, on my right side. So the last thing I'm going to do is divide both sides, do the inverse again, divide by T as follows. And if I divide by T, these two T's cancel out, okay, and I will just be left with V minus U divided by T equals the A. Okay, and that's all. You could be writing it like this, or if we like to in maths, we're a bit particular with the order of things. We like to have the subject, which is A, on the left side. Okay, so we could rewrite this, girls, as follows. A equals V minus U over T, like this. Okay, and that's all for that question. Question number 13. So I will definitely see you in the next live. Just keep a lookout on my page, give my page a follow for when I go live again, and I will get this paper definitely finished in the next live session. Okay, any questions, let me know, and if you need help with any other topics as well, just let me know, and I'll try my best to make a video on those. Okay, so see you all in the next live. Keep revising and trying your best. Angles in a polygon. Oh, of course I can. So you mean finding, for example, the sum of all the angles? Because there's like 2 different formulas that are sort of attached to that topic. But yeah, I think I know what you're asking for, so